Hello everyone, I'm Altukhov, and today I'll speak about real-time delay monitoring in software-defined networks. So, huge number of interactive network applications originates an increasing demand in advanced control over the quality of connection from the network infrastructure. However, it's a hard problem to compute an appropriate data transmission path and to configure all the network devices along this path to meet the requested end-to-end requirements of connection. And it's even harder to establish such a configuration of logically independent network devices to enable dynamic provisioning of the requested connection. Network hardware doesn't support necessary functionality to allow quality of service issues. But surprisingly, listed obstacles have been successfully overcome for systems focused on network bandwidth. Connection bandwidth is guaranteed to be minimal among bandwidths of links along the target path. And unfortunately, most quality of service metrics can't be calculated such easily. Many network services and applications are delay sensitive. And however, measurement, tuning or estimation of end-to-end delay is naturally hard in isochronous distributed system without a global core and require precise and accurate coordination of network devices. As a result, no more a system of end-to-end delay are enough precise. End-to-end packet transmission delay is equal to a sum of network transmission delay through the network infrastructure and the delay between network application and the border switch. But today we will speak only about the larger part of the network transmission delay through the infrastructure. And we assume that each network switch implements output queuing and consists of following parts. It's a packet switch fabric, it's a switch packet analyzer, one per each port, and output queue, one per each port. And queuing delay or delay in output port queues can't be measured statically because of mutual influence of flows in the network. That's why we need to capture it by sending packets from controller directly in the network. So the delay measurement starts sending a service packet in the installed path in the network. And after the packet run through the target road, it will be sent to the controller where the delay will be calculated. And the measured value will consist of two parts. It's a real end-to-end delay for target road, it's an effective part of measurement, and transmission delay between controller and switch. It's a measurement overhead. And if we want to have accurate measurement, effective part must be larger than an overhead. But in practice, the effective part may be a few microseconds and overhead maybe dozens of milliseconds, and it is a bad situation for measurement. But we can go another way, and we can send a packet to the endless loop in the network based on the target road. And after some iteration, maybe after n iterations, first switch of the road will send to controller a copy of the packet as a pulse message. And the interval between two segments pulse messages provide a good estimation of round-trip time for the target road. And although this measured value doesn't include the delay between controller and switch, it includes only jitter between controller and switch. Provided method have two problems. And the first problem is that we need to install a huge number of rules to create the loops with a big number of iterations. And we propose to use service packets, header fields to decrease this number of rules. we propose to use each field as a counter. And for example, if we use three fields, and on first switch we can increase the counter for third field. On second switch we can increase the counter for second field and drop the third counter if the value of third counter is 9. And for third switch we can increase the counter for first field and drop the counter for second field if the counter for second field is 9. For this cascade scheme, factorizes the number of required rules. And for 1000 iteration cycles and 300 fields, we require only 30 modification rules, which is not so many. And the second problem of proposed method that we measure only round trip time, but we want to obtain one-way delays. And we propose the weighted method of FTT separation. If we want to just set the round trip time, the result will be often inaccurate, but we can divide round trip time over a single hop with more accuracy. Consider a pair of switch directly connected with the link with the language of C. And let the measurement was in time interval t, and x and y was number of bytes transmitted from the switch's output queues. Then you can estimate the one-way delay as represented on the slide with this formula. And this method generates big controller load represented with big number of packet-in messages and switch statistical requests, which we need to obtain a number of bytes transmitted from switches output queues. So we have a method that can measure with great precise the round trip time for a random road in the network. But the total number of roads in the network is huge, and we can't use our method to find the delay for each road. So we assume that the delay for the random road in the network can be represented as the sum of one-hop delays for this road. Then we need just to find all one-hop delays. And we will define the delay network delay map is a structure that contains all one-hop delays. So we need to find this network delay map. A straightforward approach using the method of FTT separation can be used there, but it generates big load to controller, and we want to avoid this. So if we want to decrease load on controller, we need to decrease the number of packet-in messages and number of switch starts requests, which generates by weighted method of FTT separation. We can achieve this by increasing the time interval between two pulse messages. For this purpose, we find the loop aggregation rule, which constructs a bigger loop or bigger or equal loop from two simple loops of the network without doubling edges in the loop. This loop aggregation rule allows us to decrease network controller load, but when we use these loops, weighted method of FTT separation become not applicable. So how to obtain one-way delays without this weighted method? We propose the network delay mapping construction algorithm, whose main idea is to organize measurements in such a way to construct a system of linear equations from the set of aggregated loops of the measurement. But if we want to construct a system of linear equations, the set of aggregated loops must comply with some restrictions. First restrictions, the restriction that loops in the aggregated set must be linearly independent. Second, the number of loops must be equal to number of one-way links. And a And the third is each one-way link must be included in at least one loop. So how should we construct this set? We will start from basic set of network cycles, which is independent by its construction. And number of cycles in the basic cycle is equal to cyclomatic number, that is less than number of one-way links in the network. We can modify the basic set of network cycles by replacing some cycles from this set with aggregated cycles from this set. And result set of aggregated cycles will be independent too, because any new cycle in the set will be a sum of cycles in the previous set. But the number of cycles in the set is not enough. So we need to extend the set of aggregated cycles to number of one-way links. For this purpose, we will find all missing one-way links in the set of aggregated cycles and extend the set of aggregated cycles with these links. The result set will be independent, and the measurement results for these links we can obtain from the weighted method of property separation. Then we can construct the system of linear equations from the completed that, and the solution of this system will be network delay map. So we'll just solve some equations with the measurement results and can find the delay for each one hop delay. So now some experiment results. We tested loop-based method with weighted method of round-trip time separation to construct the delay map for shown topology. We create topology on hybrid switch and use POX controller to install all the rules in the network. In order to check method accuracy and dependence of network load, we generated an additional traffic through the specified route. And traffic generation delay will vary from 0 to 10 microseconds, and traffic packet size vary from 64 to 1,500 bytes. For the low generation route for delay vary from 1 to 10 microseconds, and for little packets from 64 for 250 bytes. The results of delay map, on the relative delay map, you can see that many one-hop delays is just a half of an RTT round-trip time. It is because the output queues wasn't built, and we just reset the round-trip time. On the average load, you can see that on some cycles will just be set the round-trip time delay, and on some links we will see that delay on one way is bigger than delay on the opposite way. So on the delay where we generated traffic, where queues were more filled, the results one hop delay are bigger than on the opposite ways. And for the very big load, where use traffic generation is less than 100 nanoseconds and packet size vary from 1,000 bytes and bigger, the delay, the constructed delay map was the delay on the way of generation traffic was bigger than on the opposite links. So we provided a method of end-to-end delay measurement that have following features. It's provide per flow delay measurement. It's enough precise to cover the vital flow influence. It's work in SDN with general switching hardware, and it can update results up to several times in a second. So, questions?
Can I ask a question about traffic generation? You said you make some traffic generation, and I'm interested is it a synthetic traffic or a traffic area application? And in the first case, what is the template of this traffic generation?
It was just TCP traffic generated by packaging, Linux packet generator. It's all the synthetic traffic.
Assume that you have endpoints connected to the switch to generate the measurement packets, and following that is compared with the traditional packet train-based measurement methods.
A little bit louder, please.
Oh, it's a bit louder. Red.
So, do you generate measurement packets from servers connected to your switching fabric? And so, have you considered also use other measurement methods like packet train?
This is an excellent question. Do I generate service packets which used for measurement? Yet these packets was generated on controller, but we generated only one packet for each loop, and it iterates and just send pulse packets, which we use to calculate the delay.
I do have one question, which is, can you say something about the size of the network you're designing for and the size in which you conducted your tests?
I've shown the topology on which I test. It's a topology from 5 switches. It's very little topology, but it will be very interesting to test this method on big topology with big number of pages. And now these results are only for small net or big topology, and for this topology, for example, the method of delay construction algorithm is not effectively applicable.
Thank you very much, Victor.